Welcome back to Boson Buzz, where we turn daunting discoveries into delightful stories. I'm Monty Molecule. Here's a thought. Human knowledge is now the deepest ocean that's ever existed. Every minute, scientists and engineers around the globe are pouring new discoveries into it. But there's a catch. We're better at pouring than we are at sailing. Finding the one piece of information you need in that ocean is like looking for a specific fish in the dark without a map. For centuries, we've been building lighthouses, journals, libraries, search engines. But what if we could give the ocean itself a voice? What if it could tell us not just where we dropped something, but where we should dive next? That's the promise of a new kind of tool. Not a smarter search engine, but a partner that has read every book, understands every idea, and can dream up connections no single human ever could. Let's make this personal. Imagine you're a researcher. Your mission is to create a new kind of plastic that's both super strong and completely biodegradable. A plastic that doesn't choke our oceans. It's a noble, urgent goal. You sit down at your computer, full of hope. You type your best keywords into a scientific database. You get back 50,000 research papers. That's not a result. That's a mountain. Each paper is dozens of pages of dense technical language. To read them all would take years. And the answer you need, the secret ingredient, the perfect chemical structure, might not even be in a paper about plastic. It might be hiding in a study about how mushrooms break down wood or in a patent for a new kind of textile glue from the 1980s. You are, quite literally, lost at sea in the ocean of human knowledge. This feeling has a name: information overload. And it's the single biggest brake on scientific progress today. For decades, our main tool to navigate this has been the keyword search. It's a powerful tool, but it's also a blunt one. It's like having a helper who can only point at things that have the label you asked for. If you ask for strong glue, it will point you to superglue and epoxy. But it won't point you to the gecko's foot, which uses microscopic hairs to stick to walls without any glue at all. The connection between stickiness and microscopic hairs is a conceptual one, not a keyword one. Our old tools are blind to those conceptual bridges. They leave the hardest work, the true discovery of connection, entirely to the overworked, overwhelmed human mind. The turning point came when we stopped asking computers to find documents and started teaching them to comprehend ideas. This is the realm of large language models, or LLMs. You've probably met them as chatbots that can write stories or answer trivia. But scientists have recruited them for a far more ambitious job: to read, understand, and internalize the entirety of published science. Think of it as hiring the most voracious, patient, and lightning-fast reader in the universe, and then giving them a permanent seat at the lab bench. The training process is epic in scale. The model is fed the text from tens of millions of research papers, textbooks, and patents. But it's not memorizing sentences like a parrot. It's doing something far more subtle. It's learning the language of science itself. It learns that the word catalyst is often in the same conversation as reaction, speed up, and surface area. It learns that quantum often leads to probability, particle, and uncertainty. It's building a massive, interconnected map of concepts in its digital mind. This isn't a map anyone drew. It's the model's own learned understanding of how every idea in science relates to every other idea. It's the ghost in the library, and it knows where every book is and what's inside. Now, our plastic researcher returns. Instead of typing keywords, they start a dialogue. They explain the problem to the AI in plain English, like talking to a brilliant colleague. I need a polymer chain that is tough like nylon, but has chemical weak points that soil bacteria can easily recognize and break apart. The AI doesn't scan for the words polymer and bacteria. It consults its vast conceptual map. It might journey from polymer chains to natural polymers like spider silk, then leap to enzymes that break down silk, then connect to a recent study on engineered bacteria that clean oil spills, and finally arrive at an obscure paper from the 1990s about UV-sensitive chemical bonds in dental fillings. In seconds, it synthesizes a novel suggestion. Consider designing a plastic with built-in UV-degradable links inspired by dental composites. Soil bacteria known to consume hydrocarbons could be trained to target the broken pieces. A starting formula might be: it has made a leap across biology, materials science, and environmental engineering. A leap that would take a human months of reading and serendipity. This is the first magic trick: deep connection. The AI spots the invisible threads between disciplines that haven't spoken to each other in decades. But the magic doesn't stop there. The most advanced systems combine this linguistic understanding with other AI powers. They can be hooked up to simulation software. So the AI doesn't just say, "Here's an idea." It can say, "Here's an idea, and here's a computer-predicted 3D model of the molecule." Our simulation shows it should be 60% stronger than current bioplastics and degrade in 6 months under standard conditions. Here is a step-by-step proposal for the first experiment to make it. Suddenly, the researcher's role transforms. They are no longer a miner sifting through endless dirt, hoping for a nugget of gold. They are an architect. The AI has provided a set of innovative, data-backed blueprints. The human's genius is now focused on choosing the most promising blueprint, refining it with their own intuition, and bringing it to life with their skill in the lab. It's a partnership. The AI handles the scale and memory. The human provides the wisdom, ethics, and creative spark. Of course, this tool is a compass, not an autopilot. Its suggestions can be wrong, biased by old data, or just plain weird. The final decision, the responsibility, and the ethical judgment always rest with the human scientist. The AI is a powerful new member of the team, but the human is still the lead investigator. What this partnership does is remove the single biggest source of frustration and delay, the feeling of searching in the dark. It illuminates the landscape of what's already known, so we can clearly see the frontier of what's unknown. The early results of this collaboration are breathtaking. These AI partners have already helped propose entirely new classes of antibiotics to fight superbugs, discovered candidate materials for next-generation batteries that charge in minutes, and suggested novel angles for capturing carbon dioxide from the air. They are acting as global, instantaneous connectors for the scientific hive mind. In the end, this isn't about artificial intelligence replacing human intelligence. It's about something more beautiful: augmented intelligence. It's about finally building the tool that lets our collective brain, all the brilliant, fragmented discoveries of our species, function as one coherent, conversational whole. For the first time in history, the left hand of chemistry can instantly know what the right hand of biology is doing, because there's a friendly, impossibly well-read translator in the middle, making the introduction. We are not being replaced, we are being connected. From a silent, overwhelming library to a chatty, genius collaborator. That's the quiet revolution reshaping how we discover everything. We're not building an oracle to give us all the answers. We're building the ultimate sounding board, one that has absorbed every idea humanity has ever published, just waiting for us to ask the next great question. It turns the ocean of knowledge from a barrier into the greatest tool we've ever had. If exploring how we're teaming up with AI to build a smarter future excites you, do us a solid. Give this video a like and subscribe to Boson Buzz. It's your support that lets us keep bringing these stories of human ingenuity to your screen. Until next time, have a safe and curious week.